Our students, the topic for today's discussion is normal forms. So, at the end of this lecture, you should be able to determine whether a given context free grammar is in one of the normal forms, Chomsky normal form or Grabach normal form, and you should be able to uh, transform a context free grammar into an equivalent grammar in Chomsky normal form and Grabach normal form. So far, you might be wondering that why we have gone for simplification of grammars. The reason for doing that is that the simplification of grammar is an important pre-step to convert a grammar into a normal form. So then the next question arises is that why do we need to have uh, a grammar represented in one of these normal forms? So the reason for this is quite simple. One is that when you convert a grammar into an equivalent normal form, then certain mathematical properties become very easy to prove. One such mathematical property is the pumping lemma. Another reason is that when the grammar is represented in one of these normal forms, then you can easily construct certain algorithms for context-free grammars. So every grammar can be represented, every context-free grammar can be represented by a grammar in Chomsky normal form and Grabach normal form. So these are the two normal forms that we would be discussing. So to begin with, Chomsky normal form. In a Chomsky normal form, every production is in one of the two simple forms. A derives BC or A derives A. So to put it simply, it means that every production of a context-free grammar represented in Chomsky normal form will have either two variables on the right hand side or a single terminal on the right hand side. Moreover, if you look at formal definition, it insists that every non-empty CFL without epsilon has a grammar G in which all productions are in one of the two simple forms, A derives BC or A derives A. It goes on a bit further to say that this grammar will have no useless symbols and obviously then no useless productions. If a grammar has all these properties, then the grammar is said to be in Chomsky normal form. Another thing which is evident by this definition is that this grammar will have no epsilon productions, and yet another one is that it will have no unit productions, because in every production the right hand side must contain two variables. So given a context free grammar, what would be the steps to convert that grammar into an equivalent Chomsky normal form? By the definition itself, by the previous slides itself, you can say that the first step would be to simplify the grammar, and that means to eliminate unit productions, epsilon productions, as well as useless productions. Second step, if there are any productions of the form AA, then they are simply copied onto the new grammar. Third step, obviously, if there is there are productions which have a length of or the bodies of length too. Those also would be copied, provided the two symbols on the right hand side of the productions are variables. Okay. Now the step 3 is that if the right hand side contains a terminal symbol, then you make sure that the right hand side contains only variables. How do we do that? That if there is a production which contains a terminal on the right hand side, we add another production in such a way that the right hand side contains variables only. So how do we do that? If the right hand side of any production is in the form of A derives AB, where A is a terminal and AB are variables, then the production is replaced by two productions. A derives XB and X derives A. Obviously, this X is, you can take any variable name over here. This is just symbolic. X, you can take D, F, whatever you feel like, as long as you conform to the conventions of of naming variables in a grammar. Once you do that, then you might end up with certain productions in which the right hand side has length of 3 or more. Now, in order to handle, now as we know, a grammar in a CNF has all productions in which the right hand side has at most two variables, or has exactly two variables, to be very correct. So if you have productions with length 3 or more, then you replace these productions by a cascade of productions. So suppose you have a production A derives B1, B2, B3 and so on. Then you replace this production by a cascade of productions. A is replaced by B1 followed by C. Now C is now additional variable being introduced, where C derives B to D. D is another additional variable being introduced. D derives B3E. E is another variable being introduced, and so on. So let's see an example. Now suppose this is an example. The grammar is clearly not in CNF because none of these productions conform to the type of productions in a CNF. So the first step is then to convert this, or sorry, simplify this grammar. Now this grammar is already simplified. It contains no epsilon productions, it contains no unit productions, and it contains no useless productions. Step 2 is to copy any productions of this form. Again, this does not contain any productions of this form. Next, we want to make sure that the right hand side has only variables. Right hand side of all productions is only variables. How do we do that? By adding additional variables. Here we have added 3 variables, X, Y, and Z. So the production SABA becomes SABX, and another production is added, X derives A. The production AAB becomes AXXY, and another production is added, Y derives B. B derives AC, becomes B derives AZ, and Z derives C. This is the production added. So this is the third step completed. Now here we see that there are productions in which the length of the body is more than 2, which is not as per the productions required productions in CNF. Hence, we need to take care of this. To take care of this, what we do is SABX. We replace that by SAC. Then C derives, and we add another production. C derives BX. The ones in reds are new productions that are being added. Then A derives XXY. It becomes A derives XD. And a new production is added. D derives XY. B derives AZ. This is fine, so it is kept as it is. And obviously, X derives A, Y derives B, and Z derives C. These were the new productions which were added in the third step. Now, this grammar is in Chomsky normal form. So the critical thing when you're asked to convert a grammar into a Chomsky normal form is to ensure that the grammar is simplified. And if it is not, then it is lengthy process. If the grammar is already simplified, then the conversion is a fairly straightforward and easy process. Moving on then to what is Greibach normal form. A Greibach normal form, a context-free language without epsilon, can be generated by a grammar for which every production is of the form A derives A alpha, where capital A is a variable, small a is a terminal, and alpha is a string of variables. If all productions are conforming to this form, then the grammar is said to be in GNF. Simply put, this means that every production contains either a single terminal on the right hand side or a single terminal followed by a string of variables. Here is an example of a grammar in GNF. S derives small a, AB, S derives B, BB, and S derives small b, B. Here we see that every production has a single terminal followed by a string of variables. Again, A derives AA, B derives BB, and A derives B. Again, here also, every production has a single terminal followed by a string of variables. And in this last production, there is no variable. See, because it says alpha belongs to V star, and V star, as we already know, includes the null string. So this grammar is now in Greibach normal form. So let's see an example. Suppose we are given a grammar which is not in Greibach normal form, such as this. S derives, there are two terminal symbols followed by one variable followed by another terminal symbol. Obviously, this grammar is not in Greibach normal form. Now, if you're given a grammar such as this, it's fairly straightforward to convert it into a Greibach normal form. You simply add a few new productions and a few new variables. So S derives small a remains as it is, but this B is replaced by a new variable B. S remains as it is, and this also is replaced by a new variable B. Similarly, this A remains as it is. The second A is replaced by a new variable A. Now, We add new productions, those just like we did when we converted into Chomsky normal form. A derives small a and B derives B. Such an example is fairly simple and straightforward to solve. Let us look at another example. Okay. Uh, let us look at another situation here. Something like this. Here we have all the others are conforming to the Grabach normal form except for one production, which is SSAB. Now, in such a situation, the approach that we took earlier is not going to work. What we can do over here is substitute for this variable A, and if we do that, then we will get this production also into the required form. To do this, what we make use of, the process that we use is called as substitution. So if we have A and B as variables, a production of the form A derives UBV can be replaced by a set of productions in which B is substituted by all strings that B derives in one step. Formally stated, suppose you have a grammar G given by VTSP. You have a production with A on the left hand side, or you have such productions, sometimes we also call them as A productions. So you have an A productions which has alpha 1, B, alpha 2. Alpha 1 and alpha 2 can be any strings, but B is a variable. And we have another production, B production, which is given by beta 1 or beta 2 or beta 3 and so on. Now this is important to note over here that this is the set of all the B productions in the grammar. Now, if you have this situation, then you can substitute for B in this manner, that now your production would become A alpha 1, beta 1, alpha 2, alpha 1, beta 2, alpha 3, 2, and so on. So we will obtain another grammar in this case. We will obtain the grammar G dash with all VTS remains the same, but the set of production changes. To obtain this grammar, we replace the production, this production, by these productions. This process is called as substitution. So sometimes you can use substitution to convert a given context-free grammar into a Grabach normal form. So let us see again. Okay, of course, if you use this method, then the language of both the grammars is the same. Hence, the grammars are equivalent. So, let's see this example that I had shown you earlier. It's very simple again. Idea for conversion for GF, if you are given such a production, then the idea is to substitute this first variable till we reach a situation where the right hand side contains a terminal as the first symbol. So in this case, we can substitute for A in the production S derives AB, we get S derives AAB, BBB, and BB, and the remaining productions remain the same. Now here we are able to convert this given grammar into GNF without much effort, simply by using substitution. Now the examples that we took were fairly simple. Can this work every time? That is a big question. Can this work every time? Does substitution always work? The answer is no. If there is left recursion, be it direct or indirect in the productions, then the substitution will not get you the desired result. What does recursion mean? So if you have a production of this form, A derives AB. This is direct recursion. Indirect recursion, S derives AB and A derives AB. Now, in such situations, no matter how many times you replace this A, you will never be able to get the correct answer. So substitution will not work. For instance, here, if I substitute for A, I will get ABB, remaining will remain the same. I'll get the first production as ABB. Again, if I replace that, I'll get ABBB. Hence, this substitution will not work in such cases. Solution is that the left recursion must be removed. How to remove left recursion and what do these generalized steps for converting a given CFG to GNF involve? We will see in the next class. However, just to give you a brief overview, first we have to convert the grammar to CNF, which involves simplification. Step 2 is to remove all direct and indirect recursion. And after removing recursion, then we apply substitutions in order to convert the given grammar into proper GNF. So thank you for today, and we will continue in the next class. Bye-bye.